So in the second part, we had a carbon-14 and a carbon-12 that were pushed through my accelerating voltage, and they were given a particular amount of energy. Each one of them has the exact same amount of energy, but as we talked extensively, they don't have the same amount of velocity, this being voltage, that being velocity. So as they travel through the next section, I can select out particular atoms. I can select out this one, or any one further on down the line, as long as they have different mass values. Now, molecularly, that might be more of an issue. But atomically, that's not. Okay? So as they're traveling through there, the next section has both a magnetic field and an electric field. Okay? So we've got a positively moving charge going through there with a given velocity, and we have an electric field in the system. What we want to happen is an object with a particular amount of velocity to travel straight through. Okay? And an object with another velocity, though very, very slightly different, to be eliminated from the possible values. Okay? So how we do this is we look first at, let's look at the magnetic field in the interaction with a positive charge. So I have this velocity in this direction. Okay? I've got a magnetic field that's heading into the board. That's what the X's are referring to. So what direction is the force that they experience? Well, using my right hand rule, and when I do this, I always make sure I have a pin in my right hand. QV, I'm pointing in the direction of the charge. I'm going to curl my fingers into the direction of the magnetic field, and my thumb is the resulting direction of the force on that charge. Now, had it been a negatively charged, obviously my thumb would flip in the opposite direction. Okay? So they're going to feel a force in this direction. And that force it experiences is QVB. Now I've left the cross product out because I've set the system up so every particle is traveling perpendicular. Okay? So velocity again, not voltage. Let me make that a little bit lower. And actually, normally when we do this problem, we put an arrow over the velocity. So each one of these particles is going to experience this force. Well, that velocity depends on this. Okay? Now, to make a proper velocity selector, I need to be able to create an electric field that will push the particle in the opposite direction. Now, positive charge, so that means that my plate is going to be here. Meaning that if there was nothing other than, or my positive plate is going to be over here. And the reason that is if you remember, when I create an electric field, okay, positive charges move in the or attempt to move in the direction of the electric field. Negative charges move in the opposite direction. With the magnetic field pushing it this way, I want the electric field to be pushing it this way. Okay? So force that object feels as it's traveling through that electric field, okay, is going to be equal to the value of the electric field times the charge. Now, we're still seeing a lot of charges floating around, and every object is going to have the exact same charge, which is really kind of cool if you think about it. Okay? So the force that object sees, that carbon-14 or carbon-12 experiences, is going to be, so the force sum, which is going to be equal to QVB plus, that's velocity, EQ. Okay? Now, one of them is going to be negative and one of them is going to be positive, so let's just jump the gun and put a negative sign right in there. Okay? Cool? So that's the force that it experiences. And now it still seems as though there's not a property. There's nothing here to select it. But if you look at it, if you look at QV over here, there's a QV over here, is equal to 1/2 mv squared. QV, that's voltage, is equal to 1/2 mv squared. QV, velocity, B, is equal to the amount of force that it experiences. So if I can solve this for Q times velocity, I can substitute it into here, and I have a way in which I can control which particles get through and which particles don't. Okay? So I'm going to do that in this little space over here by my mouse. So Q, and let's be careful, V is equal to, well, let's do it one better. Let's just simply solve for velocity. There's no point in going any further than that. Okay? Bring the 2 over there, and I'm left with 2q v is equal to mv squared. And then I'm left with 2q v. Oh, running out of room. Put it over here. Well, why don't I just do this? Dividing it out by m, and I'm left with that. I take the square root of that, and I'm left with this. Okay? So the velocity of every particle as it's traveling in here has this kind of ratio. Now that's a square root. It's not really coming through. I think that helps a little. That's the square root of that value. So the particle's velocity is based on this property. I can plug that right into that equation now. But really the important thing is now mass plays a part in this force. Okay? So I can substitute back in there and say that the force that each object experiences is equal to Q times the square root of 2Q voltage over M. And I'm just got to get my black. Minus, I just need a bigger space to work in. 2Q over M. That whole thing square rooted. V minus EQ. Okay? That is my velocity selector. Mass is now playing a key component of how much force that object is experiencing. Now, if I have it set up inappropriately, if I don't have the right value here, then what I end up getting is a system in which if it's not the right mass, let's just say it that way, then this force is going to be big. And if it's too big, if it's bigger than EQ, you end up getting more acceleration in this direction. So what ends up happening is the particle deflects. Okay? If it's too small, if it's too big, okay, this term turns small, this becomes the big term, it deflects in this direction. If it's too small, this term turns big, and it deflects up into this direction. Okay? So you're only letting in things with a particular mass, if you will. So I've basically selected out all of my particles. I've selected out anything that doesn't have the right mass value by simply traveling through this region. Okay? And setting my electric field and my magnetic field to the right proper value. Okay? Cool? So that's the velocity selector. Now I've got a whole bunch of information here. I'm just going to, basically start over again. Cool?